All right, everybody, so today we are going to be talking about the last topic for your exam tomorrow, which is freefall, okay? So what is freefall? Freefall is what happens when you take an object and you release it from a height and you allow it to fall down with the only thing affecting its movement being gravity. When that happens, okay, the object is just gonna fall straight down, okay? It's not going to curve, it's not going to go side. We're not talking about lateral movement, we're not talking about diagonal movement. We're just talking about an object being released and falling down. You've seen several of these questions in the practice assignments that you guys and girls and everybody else is working on. Okay, so what is free fall? Makes sense, things fall down. But when we think about things falling down, we think of them falling at different rates because of what their masses are and things like that. So for example, if I was to take a heavy book like this and a piece of paper and I drop them from the exact same height, which one's going to hit the ground first? What do you think? Paper or the book? Paper or the book? Obviously, you guys are going to say the paper. Well, let's see what happens. Right? Paper goes like this and takes a long time to fall down. Now, most people would say that this is because the book is heavier than the paper, but it's not. It's because there's what we call air resistance that affects the paper more than it does the book. Basically, as the napkin falls, paper is going to encounter air particles. Those air particles are going to push up on it. It's going to cause it to go like this. But we minimize air resistance by taking our piece of paper and smushing it, okay, and making it as tight as we possibly can. We'll see what happens. We'll take the book, we'll take the paper, put them at the exact same height. Which one hits the ground first? They hit the ground at the same time. Why? Because the mass of the book, the mass of the paper, doesn't matter. What matters is the strength of the gravity that's pulling them down. So what we see is here you have the book, here you have the piece of paper, right? As those two objects were falling down, what was acting on them was the same exact thing, which was gravity. Gravity acts on all objects regardless of their mass in the same exact way, in that it pulls them down, pulls them in the downward direction. Why? Because the bulk of the Earth's mass is in the center, and so you get pulled inward towards the center of the Earth. So what do we call that? We call that direction down, just for our own sakes. So we get pulled downwards towards the center of the Earth. We call that gravity, okay? Now, lots of people figured this out. Newton, Galileo, people like that. But what they were able to figure out, particularly Galileo, is Galileo was able to figure out that gravity acts on all objects in the same way, at the same rate. It pulls all objects down, okay? And as it pulls them down, what does it do? It speeds them up. So what do we call it when something gets sped up? We call it acceleration. So gravity causes acceleration. It causes what we call the acceleration due to gravity. And the acceleration due to gravity is how fast an object or how much an object changes its velocity as gravity affects it and pulls it towards the center of mass, towards the center of the Earth in this case. Okay? And on Earth, the acceleration due to gravity has a value of 9.81 approximately meters per second squared. And since it's headed in a downward direction, we mark it as a negative 9.81. So all objects that are near the Earth's surface, regardless of their mass, get accelerated at this same rate of 9.81 meters per second squared as they fall. A book, a piece of paper, an eraser, a marker, a bowling ball, an airplane, they all get affected, they all fall at the same rate of acceleration. They're going to have different momentums, they're going to have different kinetic energies, but we're not talking about that. All we're talking about is their velocities. And their velocity due to acceleration as the object falls will always be the same. Doesn't make a difference how much they weigh, quote unquote, weigh mass, we'll get to that later. What their mass is, I should say. Okay, what makes a difference is how long they're falling for is going to affect their velocity. Why? Because their velocity is affected by the acceleration. Now, we're going to figure out a problem like you might see in a test or homework in a second. Okay, so here we have a practice example. So let's say you were standing on top of a 30-meter high cliff. okay? And that's you, and you decide you want to drop, I don't know, garbage bag, let's just say, down. So that garbage bag is going to fall all the way down until it hits the ground. So my question to you, or a question that you might be posed in something like this, would be, what was your initial velocity? What was your acceleration? How long is that garbage bag in the air for? And what is the final velocity when the garbage bag hits the ground, what we would call impact velocity? So when we have a question like this, what do? We have to figure out what we know. We have to make our key. So we could label it right here on the picture. You could label it on your key in your notes. Okay, so if we're looking here, we know one value right off the beginning. The very beginning, the value that we know is the one we just did over there, which was the acceleration due to gravity. We're going to assume this is on Earth because you live on Earth. So our acceleration due to gravity is negative 9.81 meters per second squared. That's going to stay the same regardless of what object it is, garbage bag, brick. If we're on a different planet, it might be different. But on Earth, it's always negative 9.81. Now, when we let this object go, when you release something, we let him go of this pen. Am I pushing it down? No. Am I giving it any energy going down? No. The only thing that's grabbing a hold of it the second I let go is gravity. So if we look at that instant where we let it go, does it have any velocity at the instant we let it go at? No. So we can safely assume that our initial velocity for this question is a big fat 0. So we can make our initial starting velocity 0.0 meters per second. That is a safe assumption that you can make in these questions, that your original velocity is 0 meters per second. Okay, now, we know this, we know this, we know this, we know this. We need to figure out the math for this question. So how are we going to figure out the math for this question? Well, we're going to use the formulas that we have. We've got our acceleration formula, our displacement formula, and our VF squared formula. We can use those formulas to figure out the missing values in this question. Okay, so we're going to figure out the missing values for these questions. So what do we do first? I personally like to solve for time first. It's one of the most useful. It's not always going to be this way, but in this case, it's a very useful thing to do. So let's see. What formula do we have that involves initial velocity, acceleration, time, maybe final velocity, maybe not, we don't know, at least some of those. And remember, we've got our displacement of 30 meters that we had for the cliff. It's off screen now, but you remember it. It's in the video right before this. So what formula do we have that has displacement, time, acceleration, initial velocity? Maybe final velocity. Well, if we think about it, we've got the formula that we've been working on a lot, which is the displacement formula equals initial velocity times time plus 1/2 AT squared. Okay, so you've got that formula there. Now, you're sitting there going, wait a second, t's in two places. Well, let's see if we can clean this up a little bit and make it work for us. So we know our delta S. Our delta S is 30 meters, because that's how high our cliff is. We know our initial velocity is 0.0 meters per second. We don't know our time, that's what we're looking for. We do know our acceleration of negative 9.81 meters per second squared, and we're looking for t squared. You're going, t's in two places. Oh no, I can't figure this out, there's too much to do, Okay, but it's not that hard. Why? Because this is 0 times t, and 0 times anything is going to give you what? It's going to give you 0. So effectively, what we can do with this part of the formula is we can just, and so we end up with 30 meters equals 1/2 negative 9.81 meters per second squared times t squared. Now, that's much easier to work with. You only got one variable. Good, simple, easy. Okay? Now, if we look at this, we can do this. 1/2 of negative 9.8 is going to come out to negative 4.905 meters per second squared, still times t squared, equals 30 meters. Now what do you do? It's simple algebra. We're going to divide both sides by negative 4.905 meters per second squared. That's going to cancel this one out. Negative 4.905 meters per second squared. Okay? And when you do that, okay, what are you going to get? Well, make sure you have your calculators, you make sure you're doing this. Okay? And you should get an answer of is 6 2.116, and a whole bunch of other values. Second squared equals t squared. Okay? And you look at this, you go, okay, this should be negative, right? Because it's divided by negative. And you go, okay, I got t squared, I gotta get rid of that. So I'm gonna square root this side. Then I'm gonna square root this side. Oops, I can't square root a negative sign. Did I do something wrong? Yes, you did do something wrong. If we look back at the picture here, your object is falling. Now the building is 30 meters high this way. But since the building is 30 meters high this way, does the bag climb that? Does it move upwards? Or are you dropping the bag and it's moving downwards? It's moving downwards. And so we said that the default for us for down is negative. So this 30 that you have here shouldn't be a positive 30. It should be a negative 30. Why? Because the bag is falling down. So this should be negative 30, negative 30, negative 30. And then negative 30 divided by negative 4.9 gives you 6.16. Okay? Which you can square root and get an answer of approximately about 2.47 seconds equals your time. So your time should be about 2.47 seconds. Now, we can use that time in order to figure out our final velocity. And so our final velocity, if we look at it, okay, what are we going to do? Well, we're going to use the acceleration formula to figure that out. So, we can use this formula now in order to figure out our final velocity. So, we rearrange the formula. When we rearrange the formula, multiply t on both sides, you add v on both sides, and vi on both sides, you get vf equals vi plus a times t. Okay? So now we can plug our values in. So this is 0.0 meters per second plus negative 9.81 meters per second squared times 2.47. Right? And when you multiply 9.81 times 2.47, you get an answer of right around negative 25 meters per second. Why is it negative? Because the velocity is headed downward. So, you can use this value of negative 9.81 anytime you have a question where it says the object falls, the object is dropped, the object is moving vertically, okay? You can use this as long as it's on Earth. If it's on another planet like Krypton or Xandar or Hoth, okay? Those planets are all going to have their own individualized acceleration due to gravity. You would have to know that acceleration due to gravity, or you would have to be given the information in order to figure that out. So you should now be able to figure out any free fall question that you are given. All right?